Hi everyone, my name is Soham, and I'm going to be walking through CS61B Spring 2020 Midterm 1 Question 3B. As a preface, if you guys have any questions how swap up works, I walked over swap up in the previous video, so go over that video. But this video will focus on 3B. Fill in the method swap up list so that it destructively returns the list resulting from applying the same algorithm as swap up. This version should never execute a new operator except for creating one temporary int list that is used to make sure there's a predecessor to every item in the list. Okay, so when I read this line, I don't really know what this means, but I'll look at the skeleton code and hopefully things will clear up. And as I go through this video, my goal is to give some intuition on how I approach these problems so they become more attainable and more easy to do in the future. Okay, let's keep reading. Otherwise, your program should reuse the same intlist objects as its input. Since the head of the intlist type defined here on page 2 is declared final, your solution must not attempt to assign to any of the head fields. Okay, this is a quick summary of everything we learned so far. When it says destructively, that means, let's say we're given some linked list. Let's say 2020, the generic linked list. Right? After we execute dswapup list on L, our output should just be the linked list containing these exact same elements, but moving the pointers around, right? So since we know from the previous example, when we call dswapup list on 2020, it'll become 0202. So what we want to return is a list that goes 0, 2, right? 0, 2, okay? And this looks a little messy, but the gist is that all we want to do in a destructive function call is rearrange the pointers, right? We're not creating any new links except for this temporary one that they're going to somehow help us with, okay? So that's just a quick explanation of how destructive works. Now with that in mind, the next step after understanding the question is to understand the skeleton code that's provided. Okay, so let's look at the skeleton code. And I'm going to walk through this as if I'm seeing it for the first time with you guys. Do not assign to any of the head fields. This means that the head fields are these numbers. So it doesn't want us to create a new linked list by swapping numbers. It wants us to create a new linked list by swapping pointers, right? Okay, let's keep reading. Return the result of applying the dswap algorithm to L destructively does not create new int list objects. Okay, with this in mind, let's look at the base case. The base case we see here goes if with some space and then return L, right? So we know here from the previous part that the base case was if L is null, or if L is a one element link, i.e. L.tail is null, we just return L, okay? And we could put that in right now, and I'm guessing that'll work as the base case, but let's be a little safe and look at the rest of the problem to see what's happening. But for now, we can put it in here. If L is equal to null, or L.tail is equal to null. And the reason I came to this conclusion is from the previous part, and I still haven't seen the rest of the problem yet, so I'm not really sure if this is correct. But let's keep going, and then we'll verify at the end. Okay, so now it creates some int list holder, which is equal to a new int list with first element 0, second link L. Okay. And this is probably the temporary, it's the temp that they talked to us about. They told us about in the introduction. The temp link, okay? And whenever I walk through a problem, I really like having a little diagram of a linked list in some scratch paper so I can kind of see what's going on. So I'm going to replicate that process right now. Okay, so we have some link L, and now we have some holder, right? Okay, so that's all we've done so far. Now we also have some guy named Prev, right, who points to holder. I'm just looking at the skeleton code to see as much I can get out of it as possible, right? Now we see that we have some while loop, right? And since it's destructive, we see that here it's using iteration to destructively change the pointers, right? Okay, let's look inside the loop to see what we can recognize. So here, we create two int list pointers, right? Two int list objects, L0 and L1. Okay, so L0 is going to be prev.tail, and we're just looking at the first iteration of the while loop, right? So we have L0 is prev.tail, right? I'm just looking at this diagram right here. And L1 is L0.tail. Okay, so we see here that in order in the list, right, it goes prev, first it goes prev, then L0, then L1, right? Something to keep note of. So I just kept note of that. Okay, now we have an if and an else block. And this seems to me like the two cases that we mentioned from the previous problem, right? This case is probably the case that's more complicated, right? When we want to swap first and second, right? And this is the case where we don't want to do anything. Do nothing. Right? Okay. This is just intuition right now. We haven't jumped to any conclusions. So we see here that when we want to swap the first and second, that means we're probably swapping the pointers of L0 and L1, right? So let's see what happens in this case, right? We're just looking at this case right now. Okay. So when we work with linked lists, it's really good to see what our end result should be, right? What should happen after swapping these pointers? Let's think about that. So we know that 2, right, must point to 2, right? Because our linked list should ideally go 0, 2, 2, 0 after we swap the first two elements, right? Which means in terms of pointers, the changes that we have to do are to have L0 point here, right? That's the first change that we have to do. The second change that we have to do is to have L1's tail, right, this guy, be L0, right? Because we're just switching the order. I'm looking at our desired end result, and I'm telling myself what changes in pointers do we have to make. So we see that L1's tail must point to L0. L0's tail must point to this L1's old tail, right? Do we have to do any other changes? So we see here that prev must also change. Why should prev change, right? Intuitively, we have some ordering of this linked list, right? We don't really know what prev is doing yet, but we know that it should be in order, right? So prev was initially pointing to this 2 block, but now, since we swapped L1 and L0, prev should be pointing to L1, right? So we can put that here. Okay, that's all the changes we have to do when we want to swap two elements, right? So we've kind of dealt with this case. Now for the do nothing case, well, I mean, that's easy because we don't have to do anything, right? But we still haven't figured out how do we move on to the next iteration of the while loop, right? Because each iteration of the while loop, what we want to do is take these L0 and L1 pointers and just move them. Oh, dang it. The arrows are not connected. That's okay. And then just move them one down in the linked list, right? We want to keep moving this process. But we still haven't figured out how to start moving down this linked list. So we see here that L0 and L1 are determined by prev, right? So in order to move L0 and L1 down the linked list, we need to move prev down the linked list, right? So each time we should say prev, you're going to move on to the next person. Okay. So with this in mind, let's try to fill out this if and else block, okay? This while condition, we know it's going to be something along the lines of while prev is not equal to null, right? We don't know exactly yet. Let's figure this out later. I'm going to put a star here. Because it's easier to see when we're going to get to the end by just playing through an example. But let's first figure out the body of the while loop, right? Because that's what we talked about right now. Okay, so how do we know when we want to do a swap? Right? How do we know when we want to do a swap? Well, we compare if L1 dot head, right? We compare and we see if L0 dot head, right, is greater than L1 dot head, it means we need to do a swap. Okay? So let me just put that in here. if L0 dot head is greater than L1 dot head, it means we have to do a swap, right? More specifically, we just want to swap these adjacent elements. So we said here, right, we've already figured out how the pointers need to change. Right, L0's dot tail must be L1's old dot tail, right? Then L1's dot tail must be L0, right? I'm just going through these pointers that we've already figured out. Okay, now Prev, right? Prev's tail must also change. More specifically, it must change to, who is it pointing to? L1, right? So Prev dot tail equals L1. Okay, now we also must move Prev down, right? That's why we see we have this reassignment to Prev right here. We must move Prev to the next link, right? One down in this list. So which is the next one? Well, since we just move L1 to the front, it's going to be L1, right? So we say Prev is equal to L1. And we also note that it's equally valid to say Prev.tail here. The only reason we set L1 is because it's like a bit shorter. So easier to type up. Okay. Now, looking at this else block, in the else block, we don't have any swaps, right? All we do is just move Prev down by 1. So we said Prev is going to be equal to Prev.tail, which in this case is L0, right? It's going to be equal to L0. Okay. Now we figured out the body of the while loop. So let's try to figure out what this ending condition is, right? Let's try to figure this thing out. We know it's something about Prev being null. But is it Prev.tail, Prev.tail.tail? We haven't figured out yet. And the best way to figure out is by example, in my opinion. Right? So let's walk through an example and let's try to figure out. So the first iteration, let's see if we can capture this all. I just want to slide the pointers. That would be nice. Perfect. Okay. The first iteration is here, right? Second iteration, it's like this, right? Then the third iteration, it's like here. And then this is the last iteration, right? Because L0 and L1 at the end. So we like to note that this is the last. Okay. How do we know this is the last, right? Okay. So let's go on to like one past the last, right? Ooh, this is a problem now, right? At this point, we should exit the while loop. What is happening at this point? At this point, we have Prev's dot tail is equal to null. Okay? So what we've concluded is while Prev, right? Let's move to the screen. Prev dot tail is not equal to null, right? And let me just bring these guys back. Okay, perfect. So with this in mind, let's quickly go back to the top to make sure that our base case makes sense. And I think it makes sense because all we've really concluded is if L is equal to null or L.tail is equal to null, there's no need to swap. And we see here that in the while loop, that also makes sense. So the base case is a go. Okay, this is the final solution, but before I end this video, I want to give you guys one final thing to think about. Okay, so at the bottom here, we have this return holder.tail, right? And let's think about why this line makes sense. So we see here that this is our holder in this example, okay? It's a link that points to the first element in our new linked list, right? So at the end, holder will probably point to the link going 0, 2, 0, 2, right? But, okay, and then when we return holder.tail, we see that it's correct. So the question I have for you guys is, would it be valid to just return L? Right? Is this valid? Because L used to be the start of our new linked list, so it seems like more effort to do holder.tail. Is this valid? Okay, so I want you guys to take a second to think about this. So the answer is this is not valid. The reason it's not valid is because L could have moved, right? In this case, L is always pointing to the to link, right? This to link. So if we just returned L, we wouldn't return the entirety of the linked list, okay? That's really important. It's really important to understand the entirety of the code that's given, not just the little skeleton code that we have to fill out. Okay, so with that, that's all for Spring 2020 CS61B Midterm 1 Question 3B. Thank you guys for listening.